Hi, I'm Veli from Greenwood Solutions. This week's presentation is on lithium. There's a lot of different battery chemistries and a lot of different applications from mobile phones all the way to energy storage and EVs in between. Lithium is the lightest of all metals and has the greatest electrochemical potential and provides the largest specific energy per weight compared to traditional battery materials. Interestingly enough, Australia is the biggest supplier of lithium, so the question is always asked, why aren't we producing batteries? And hopefully we will in the future. So it's a product, it's a mineral that's mined, it's an element, and there's different ways of mining it, and Tesla at the moment are looking at some more, I suppose, environmental friendly ways of mining the lithium, and they've been asking their suppliers to look into this, where you're actually excavating the area for lithium and then replacing all that soil after the lithium has been extracted back into situ, which I think is pretty positive approach. Lithium ion uses a cathode, positive electrode, an anode, negative electrode, and electrolyte as a conductor. During discharge, the ions flow from the anode to the cathode through the electrolyte and separator. The direction the ions flow from the cathode to the anode is reversed when charging. So one way discharge, the other way charge. Most companies shifted to a graphite anode to attain a flatter discharge curve because it has long-term stability, and by the way is used in lead pencils. A future material that promises to enhance the performance of lithium ion is graphene. Lithium cobalt oxide, LCO. Lithium manganese oxide, LMO. Lithium nickel manganese cobalt oxide, they're starting to get more complicated. Lithium iron phosphate. Lithium nickel cobalt aluminium oxide. And lithium titanate. With lithium, there's a lot of talk of energy density. Now, obviously for applications like mobile phones and laptops, you want something really energy dense because there's no way you want a heavy battery. No, the consumer's not going to accept a mobile phone or a cell phone that's 5 kilos or a laptop that's 15. So you can see where that application, but with specific energy density, with those particular lithium solutions that are very energy dense, there can be a trade-off in regards to safety in some respects and also longevity, so that's something to be aware of. Lithium cobalt oxide, LCO. Its high specific energy makes it good for mobile phones, laptops and digital cameras. The drawback of lithium cobalt is a relatively short lifespan, low thermal stability and limited load capabilities. So not really applicable for renewable energy storage applications. Lithium manganese oxide, LMO. So lithium manganese oxide is the next one on our list. This particular chemistry has lower internal resistance and good current handling. Has high thermal stability and enhanced safety. But the cycle and calendar life are limited. Lithium manganese is used for power tools, medical instruments, as well as hybrid and electric vehicles. Lithium nickel manganese cobalt oxide, NMC. NMC combines nickel and manganese. Nickel is known for its high specific energy but poor stability. But manganese has the benefit of achieving low internal resistance but has a low specific energy. Combining the materials enhances each other's strengths. NMC is the battery of choice for power tools, e-bikes and other electric powertrains. Lithium iron phosphate, LFP. The key benefits of lithium iron phosphate are high current rating and long cycle life, good thermal stability, enhanced safety and tolerance if abused. And lithium iron phosphate is more tolerant to full charge conditions. But it has a higher self-discharge than other lithium batteries, which can cause balancing issues with aging. Lithium nickel cobalt aluminium oxide, NCA. High specific energy, reasonably good specific power and a long lifespan. Not so safe, and it's pretty costly. The aluminium does add stability. High energy and good power densities makes NCA a candidate for EV powertrains. Now, how important is energy density? In an EV situation, of course, and laptops and mobile phones, it is. But from a stationary battery perspective, if you've got the area, it's not such a bad idea to go for a less energy dense option to something that may be more thermally stable and have a longer life because you've got the room. At the end of the day, it's going to come down to cost with all these other factors looked at. Lithium titanate, LTO, can be fast charged, has high discharge current of 10C or 10 times the rated capacity, which is pretty incredible. The cycle count is said to be higher than that of a regular lithium-ion chemistry. Lithium titanate is safe, has excellent low temperature discharge characteristics. It's starting to sound pretty good, isn't it? But expensive. Some uses include electric powertrains, UPS and solar powered street lighting. NCA enjoys the high specific energy, as can be seen from the graph. Manganese and phosphate are superior in terms of specific power and thermal stability, and lithium titanate has the best lifespan. Now this little table shows some major brands out there and what kind of chemistry they're using. Now you can see very quickly that NMC seems to be the chemistry of choice for both the Tesla product, LG, Samsung and Sun and Shine. Whereas PowerPlus, Simplify and BYD use the safer lithium iron phosphate solution. Now the most exciting battery at the moment from the lithium stable is lithium titanate and really good longevity on life, etc. There's some really good attributes, but very expensive, but that can change quickly. Conclusion. There are many different lithium batteries out in the market. Some of the important criteria include thermal stability, energy density and longevity. Lithium nickel manganese cobalt oxide, NMC, is used by a few manufacturers. Manganese and phosphate are superior in terms of specific power and thermal stability. Thanks so much for watching this presentation on the different lithium chemistries that are available. If you have any inquiries, any questions, any answers, please feel free to drop us a line. Thanks very much. Bye.